Hey guys, so yesterday we talked about like insects breathing and how like their size is limited by the oxygen in the air around us. And if we had like more oxygen in the air, we would have much bigger bugs. And I showed you some pictures of some giant bugs that existed, back in the day when dinosaurs were around. If you haven't yet like clicked on the grasshopper, there is a video. Definitely like pause this and just watch the video now on insect breathing because it is really simple. They just have holes in their body and air diffuses in. Do you remember diffusion? Diffusion is the movement of anything from high concentration to low concentration. But the video gives you a little bit more detail and it's totally worth watching. So, speaking of diffusion, let's look at how some other animals breathe. And this is a salamander. And these exist in North America. They aren't right here in Minnesota. These exist kind of near like Tennessee in the southeastern United States. But these are called hellbenders as their common name because they're so big. Like as far as a salamander goes, these things are pretty large. And they have these folds of skin that makes them look like super wrinkly, and they live their entire life in the water. And so these are salamanders that don't come out on land. And this folds of skin are there to add surface area. So think about math. Surface area would be just the amount of skin on the body. And the more surface area that this hellbender has, the more oxygen his skin can come in contact with. And there's oxygen in the water, and that oxygen in the water can diffuse into the salamander's skin, and it lets CO2 diffuse out into the water around it. So, like, this salamander can just live in the water and it gets all the air that it needs, and it never has to like go up and gulp air. It never has to like worry about gills or anything. It just kind of sits in the water and it's able to breathe. And it's able to do that because of the huge folds of skin on its body and the large surface area. So really, there is a video on hellbenders and the problems that they have. So definitely like pause this video if you want. Go to your notes, click on the hellbender here, and check out the video on the problems that they're facing in North America. So go ahead and do that now. And now that you're back, let's talk about some other salamanders. So on the next slide, on slide 20, these are more typical. These salamanders breathe with lungs, and you're welcome to click on the pictures. It just kind of zooms in, but these have really, really simple lungs. So yours, if you remember yesterday, have all these little tiny little air sacs called alveoli in them. And each one of those is surrounded by blood vessels to allow air to diffuse into your blood and CO2 to diffuse back into your lungs, and then you can exhale it or breathe it out. These salamanders have very simple lungs. You could think of them as like just two bags, and therefore they aren't nearly as efficient as your lungs are. But they still breathe with lungs. They still have a muscle that allows them to pump air into and out of their lungs, but they don't have a diaphragm like you and I do. They actually use like a buccal or a buccal. I've heard it pronounced either way, a buccal pump, and it's in their throat. It's actually a bone connected to the muscle that expands the throat and then pushes the throat back down, and that's how they pump air into and out of their lungs. And you can see that sometimes if you watch like salamander breathing. Check it out on YouTube if you want. But it's called a buccal or buccal pump. So now we're going into fish, and fish and some salamanders when they're younger, or if they never like metamorph into an adult, they have gills. And definitely click this video for watching fish breathe and how the gills work and oxygen exchange. So go ahead and pause this one, go to your notes, click on this video, and watch how fish breathe. And now that you're back, these guys, there's two ways in which fish breathe, and the best way to breathe is called a counter current exchange system. So you notice it says it's more efficient up here, and that basically means that the fish pumps water through its mouth and through the gills in a direction from the front of the head towards the tail, and at the same time its heart is pumping blood in the opposite direction from its heart up towards its mouth through the gills. And so the blood passes the water in different directions. And what that allows for is better diffusion of air. So if you can imagine like water coming into a countercurrent exchange system is high in oxygen. And at this point in time, it touches blood that's really, really picked up a lot of oxygen from the water, but it's still got a little bit of CO2 in it. So there's high amounts of oxygen here and a high amount of oxygen here, but there's a little bit higher oxygen right here in this water. And so diffusion can still occur here. And diffusion can occur down this whole length because as you get here, the oxygen in the water has gotten much lower in concentration, but the amount of oxygen in the blood right here is really low. So diffusion can occur this whole length of contact as water passes over the blood. Now, if you look at this concurrent exchange, when the water and the blood flow in the same direction, we get a little bit different story. Remember that diffusion is the movement of things from high to low concentration, and it'll do that till it reaches equilibrium. So what happens in this exchange system is you get high water or high amounts of oxygen in the water and a low amount of oxygen in the blood, and diffusion happens right here really quickly. And it happens here, and it happens here, and it happens here, and eventually, kind of about in the middle of their contact, they reach about equilibrium. So when that happens, there's about the same amount of oxygen in the blood as there is in the water, and diffusion kind of just stops then. And so the rest of the time they're in contact, nothing really happens. You just still maintain equilibrium until the water separates from the blood. And so the more efficient way to do it is the one up top here in this picture, that when water passes in the opposite direction of blood, because you can get diffusion occurring across this membrane the whole time they're in contact. And then the one that I want to focus on today before we get into birds a little bit tomorrow is the whales and dolphins and everything. So they breathe like you and I do. And you remember that in evolution, we learned that the blowhole is actually the nostril, and it's migrated during early development when the dolphin and the whale are developing inside of mom. It moves to the top of their head. And what happens is air is breathed in through that blowhole and it's exited through that blowhole, much like you can breathe in and out through your nose. And it goes into a very efficient lung or a pair of lungs inside of the dolphin or the whale. And you might think you're good at breathing, but compared to a whale or a dolphin, you're pretty terrible. Those guys live underneath the water and they need to hold their breath for extreme amounts of time. So whales and dolphins are super good at forcing all of the air out of their lungs, like squeezing all of it out and then taking a huge breath in so they can hold it for a long time. So they're essentially like squeezing the bag till there's nothing in the bag and then opening up really big. And you and I don't do that. We don't need to. We're surrounded by air all the time. We breathe all the time. So when we squeeze our lungs out, when we breathe out really, really hard, there's still a lot of air left in our lungs. We still have about 60% of our lungs filled with like leftover air. 60%. We only breathe out like 40%. And that means we only breathe in then about 40%. Even on your biggest like breath, you're only filling your lungs back up about 40%. So you have a bunch of used up air in there all the time. So we are not good at using our lungs that we have. Birds, on the other hand, are amazing. Dolphins and whales are amazing. We're not. I do want to point out one more misconception about whales. So here's a little video. A lot of people think that like whales swallow water and then somehow blow it out of their blowhole. I can think of like the movie Pinocchio, and maybe you haven't seen it because it's really old, but like he gets eaten by a whale and then, you know, shot out of the blowhole. And I even think like Dory does that in Finding Nemo. Like they get swallowed after she talks to the whale and the whale carries them to Sydney and then like gets shot out of the blowhole of the whale. This just does not happen. Okay? It's totally not true. What you see when a whale blows out all that air is actually from their lungs. It's really, really hot air. And when it comes in contact with the air and the water around it, it's actually like steam. The inside of the whale is so warm. It's actually like a steam shot that's coming out of their lungs, the humidity out of there. And then the other thing too is there is water on the surface of the whale as it comes up out of the water. And some of that water, with the force of the air ejected out of that nostril, gets shot up into the air. But the whale is not swallowing water and shooting it out of its nose. That's not what's occurring here. It's steam from inside of the whale and leftover water on the top of the whale that's being shot up when it exits. So anyway, just wanted to clear that up if you thought that was something that was really happening. There's a video, click that, and talks about like whales breathing and dolphins breathing. So definitely check that one out if you haven't done that. And tomorrow, let's touch base about birds, because birds breathe in an amazing way. And that'll be the end of our respiration unit. So if you haven't done this yet, click on that, watch that. So you got a couple videos in the notes to watch. Take it easy, enjoy your Friday and your weekend.